All right, welcome back, Hononegah, Algebra 1. And this first one in on notes is kind of a group or a partner activity. So I'm going to go ahead and skip that activity and kind of go straight into, and I know there's some things here like make a table, use the table to sketch a graph, describe the domain, describe the range, and we're going to be doing all that, but I kind of want to go through it as how it would be done because again, we don't have that partner activity. So here we go. Square root functions. This is what we're going to be graphing. We're going to be graphing square root functions or things that look like this, and I'm circling it up here. Y equals the square root of x. And so there's some domain issues. You remember how always we talk about domain is all real numbers. Domain is all real numbers. Well, domain is not always all real numbers. And I know some of you kind of think about that it would be all real numbers, but ultimately whatever is under the radical, so whatever is under the square root, this part right here, whatever is under the square root, must be greater than or equal to 0. That is your domain. Now, what that does is it gives us the x values that we should use for our xy chart, and then it gives us then the range after that. So that's kind of the order that we'll do things in. Is the first we'll find the domain, then we'll make an XY chart, and then we'll actually find the range. So again, 3 to 5 ordered pairs is basically all I want. We don't really need more than that. So we just need about 3, 4, or 5 points. Okay, here we go. So whatever is under the square root must be greater than or equal to 0. So under this square root is at x minus 5. It needs to be greater than or equal to 0. So solving that, x would be greater than or equal to 5. That is your domain. So the domain is x is greater than or equal to 5. What that means is when you're doing your XY chart, 5 is the first value of the XY chart, and the numbers must go up from there. So numbers like 6 would be a good number to put in for x. Now, some of you are going to think this is random, but you could put 7, 8, 9, 10, things like that. But I only want the ones that are going to come out nice and even. So I'm going to put 9 in for x. So here we go. 5 in for x. What is it? 5 minus 5 is 0. Square root of 0 is 0. Times 3 is still 0. 6 minus 5 is 1. Square root of 1 is 1. Times 3 would be 3. 9 minus 5 is 4. Square root of 4 is 2. And 2 times 3 is 6. So I know that could be a little bit confusing, but what I just did was I found the first value, and then I found just x values that are greater than that. So 6, 3, 9, 6. And what it makes is half a parabola. Okay, it's a sideways parabola, and it's half a sideways parabola. Now, let's talk about range. So the range is always the y values, and the first value in the xy chart, and I don't know why it says 5 there, the first value in the xy chart is 0, and so all the values are greater than or going up from 0. So I didn't have a lot of room to do this question, but hopefully that helps. So now the next one, the domain. Only take what is under the radical and make it greater than or equal to 0. So the domain in this case is x is greater than or equal to 0. Make an xy chart starting at 0. So again, the answer for your domain is where you start at. So I want numbers to go up from 0. So plug 0 in for x. The square root of 0 is 0 plus 3. The square root of 1 is 1 plus 3. The square root of 4 is 2 plus 3. And the square root of 9 is 3 plus 3. So I'm graphing those points. 0, 3, 1, 4, 4, 5, 9, 6. And so again, it makes half a parabola. It makes like a ray. It only goes in one direction. Do not put an arrow on both ends. Only put an arrow on one end. So the range, the y values are going up from 3. So the range in this case, notice the y side of the xy chart, the y values are going up from 3. A graphing calculator can help on this. So if you type in y equals and then type in the function and hit graph and also hit second and graph, that would give you an idea as to what the picture should look like. So continuing here. I'm going to do these even though they are U tries. So if you want to hit pause and try them yourself and see what happens. Whatever is under the radical must be greater than or equal to 0. That's your domain. Make an XY chart using your domain. So 1, 0, 1, 4, 9. So again, I'm trying to come up with ones that come out nice and pretty. Plug square root of 0, minus 4. Square root of 1, minus 4. Square root of 4, minus 4. And the square root of 9, minus 4. Plot those. 0, negative 4. 1, negative 3. 4, negative 2. 9, negative 1. Again, it's half a sideways parabola. The range is always the y values, so the y values are going greater than negative 4. Whatever is under the square root, greater than or equal to 0, that is your domain. Your XY chart then starts at negative 5 and goes up from there. So when I plug negative 5 in, negative 5 plus 5 in the square root, negative 4 plus 5 in the square root, negative 1 plus 5 and then the square root, and 4 plus 5 in the square root. So negative 5, 0, negative 4, 1, negative 1, 2, 4, 3. Again, only goes in one direction. The range, y is greater than or equal to 0. It's always the start of your XY chart. Well, if you want a transformation, okay, and now things are getting a little bit more challenging. Remember when we did transformations before? If you want to translate something left or right, you're going to add or subtract inside the radical. If you want to move something up or down, translation up or down, you're going to add or subtract in the end. If you want to do a reflection on the x-axis, you put the negative outside. If you want to put a reflection on the y-axis, the negatives on the inside. Vertical stretch and a vertical shrink. If the number is above 1, you're multiplying by a number above 1, it's a vertical stretch. If you're multiplying by a number below 1. So now, just kind of laying this out here. Y equals, there could be a negative out here with a number. There could be a negative in here with a plus or a minus a number. And then there could be something outside with a number. So those are all the different places that you could have a number or could have something that happens. And each one of those means something. So if I have a negative on the outside, that's a reflection on x-axis. If I have a number on the outside in front of this, this is either a vertical stretch or a vertical shrink. If you have a negative sign inside, this again is a reflection, and this time on the x-axis. Adding or subtracting, that's a translation, and it's either left or right. A number outside here, that is also a translation, up or down. Again, you're not going to have all of those, but that is all the different places that I could put something. So when we're talking about describing the transformation, you have to understand what is being done and where is it located. So here we go. I just want to describe this, okay? We'll get to the graph in just a second. The negative sign out in front, right here, and I'm going to erase all this in just a second, but a negative sign out in front, that is a reflection on the x-axis. A -2 on the inside, okay? This is just like when we did parabolas. A -2 is a translation to the right 2. So you can describe this without even graphing it. Now, I'm going to go ahead and graph this and see what happens. So first I have to find the domain. So x minus 2 is greater than or equal to 0. X is greater than or equal to 2, which means 2 is where I start. 3, 7. Those would all be good numbers here. All right, so let's 2 minus 2 is 0. Square root of 0 is still 0, negative. 3 minus 2 is 1. Square root of 1 is 1, negative. 7 minus 2 is 4. Square root of 4 is 2, negative. So notice the negative outside. So the picture of this one, 2, 0, 3, negative 1, 4, 5, 6, 7, negative 2. So it's a reflection on the x-axis. So notice it's going down instead of up. And a translation to the right too. Now, I know it's not asked in this question, but really range is a more challenging one. Y is less than or equal to 0. Why is the range going down? Because the numbers are going down. It's the downward side of the sideways parabola. So this gets a little more challenging here with domain and range. I like to just describe it first. So what does each one of these do? The negative sign out in front, that's a reflection on the x-axis. The minus 3, that's a translation right 3. On the outside, a minus 2 is another translation, this time down 2. So I can actually describe without actually graphing it. Now let's talk about graphing. Whatever is under the radical must be greater than or equal to 0. This is your domain. XY chart. Start with your domain and go up. So x is greater than. So 4 and 7. Plug 3 in. Again, there's a lot of math going on here. 3 minus 3 is 0. Square root of 0 is still 0. Times negative 2 is still 0. Minus 2. 4 minus 3 is 1. Square root of 1 is 1. Times negative 2 is negative 2. Minus 2 is negative 4. It's probably a lot for some of you to understand. I'm putting 7 in for x. So 7 minus 3 is 4. Square root of 4 is 2. Times the negative 2 is negative 4. Minus 2 is negative 6. So 3, negative 2, 4, negative 4, 7, negative 6. Find the domain and graph. So again, I'm back to whatever is under the radical. And this gets, a little bit more challenging. Greater than or equal to 0. So x is actually less than or equal to 0 when I divide by negative 1. I'm going to go back and do that again because that was probably a little rough. Whatever is under the radical must be greater than or equal to 0. Solve. Wait a minute. What happens when I divide by a negative? I switch the inequality symbol. So now, with my XY chart, if my domain is going down, then I need my numbers to go down. So when I plug 0 in, 0, negative to 0 would still be 0. Negative, negative 1, square root. Negative, negative 4, square root. What happens is this picture actually goes the opposite direction. So it's a reflection on the y-axis. It goes left instead of right. So that can be a little bit troublesome. So whatever is under the square root must be greater than or equal to 0. But when you solve it, I end up flipping the inequality symbol because I divided by a negative. So now when I do my XY chart and I start at 1, my numbers actually need to go down from 1. So 1, 0, and let's go negative 3. So negative 1 plus 1 is 0, square root minus 3. 0 plus 1 is 1, square root minus 3. So when I plug negative 3 in, I get negative 1. Again, because the negative sign under the radical, what ends up happening with this question is it ends up being a square root. It ends up being half a parabola, but it ends up being half a parabola going left instead of right. Okay, this can be a challenging one. Make sure you get the worksheet. Ask questions. Graphing is going to also be challenging for those of you that do not have printer access. So make yourself just make yourself a little bit of a grid and do your best on your graphing. But here we go, section 10.1, graphing square root functions. Good luck. Be safe. Hopefully everybody is doing well. And ask questions on a Google Meet or Zoom if you need to, or email your teacher.